Hello again. We are going to continue on Unit 8 as review. We're going to look at problems 12, 13, and 15. For some reason, it skips number 14 because I think it's just based on the problems in the packet. Anyways, let's continue on. So for number 12 and 13, we're looking at these two triangles. Triangle RST and triangle ABC. And it says that these two triangles are congruent. That means that they're equal to each other. So if it's congruent, that means the sides are equal to one another. So side R is congruent to A. Side RS. So RS is congruent to AB. Angle R is congruent to angle A. And so we can find specific information if they're congruent to one another. So the first thing it wants you to find is X. We know that angle S is equal to 5x plus 20. And then we know that angle B is equal to 3x plus 40. Okay, and we know that these two angles are congruent because these two triangles are congruent. And if you look, angle S is the second letter of triangle RST, and angle B is the second letter in triangle ABC. So we know that these two angles right here, angle S and angle B, are congruent to one another, and they're corresponding in the different triangles, meaning that this angle is corresponding to angle B. So that means we can set them equal to each other. So in order to solve for x, we're going to go 5x plus 20, because that's angle S, and we're going to set it equal to angle B, which is 3x plus 40. So we have this algebraic equation. And what we're going to do is get x on one side of the equal sign, and then we are going to put the numbers on the other side of the equal sign. So I'm going to subtract 3x to both sides, and we're going to get 2x plus 20 equals 40, and then we're going to subtract 20 to both sides of the equation. That cancels out, and we get 2x equals 20. Divide both sides by 2. X is going to equal 20 divided by 2, or 10. So we just solved for x. And now we're going to solve for y. Essentially, it's the same situation. We know that side ST corresponds to side BC. So we're just going to set 2y minus 8 equal to y plus 13. And we're going to solve for y. So we have two equations that are set equal to each other. So we're going to subtract y to both sides because we want to get y by itself on one side of the equal sign. So 2y minus y is going to be y, and we're going to have minus 8 equals 13. So then we're going to add 8 to both sides, and that gives us y equals 13 plus 8, that is 21. So we just solved for x and y. So for problem 12, x is going to be 10. For problem 13, y is equal to 21. Now, we're going to be looking at problem 15. It says that triangle CBX is congruent to triangle SML. So that gives you multiple choice solutions. And I'm just turning on this Chromebook. So just give me 1 second so I can see the problem. So essentially, when we look at problem 15, it says determine which statement is true given that triangle CBX is congruent to SML. So the first choice that we have, it says that side MO is congruent to SL. Well, is there an M and an O? No, it's M, S, and ML. So there is no side MO. So we know that F is not a solution. When we look at G, it says side XC is congruent to ML. Well, if we look at it, basically XC is congruent to LS, so that is not a solution. And then it says angle X is like corresponding or congruent to S. And if you look, that it does not match up because angle X corresponds to angle L. All right, and the last solution is basically saying that angle XCB is congruent to angle LSM. And if we look, it does make sense because it says angle XCB right here, this angle XCB is congruent to LSM. LSM. And if you look, these two angles basically correspond to one another. So that would be the solution. Our solution would be J from the multiple choice. And that would be that right there. Okay, so we're going to move on to problem 20, which is write a two-column proof. I'm going to do that right now. Okay, so number 20. We have, it says write a two-column proof. Okay, so I'm going to write the triangle that is given. We have triangle LMNO, and then 1 and 2 right there. And I'm just going to write what's given. It says given triangle LMN is isosceles with side LM being congruent to NM and side MO bisects angle LMN. And it wants us to prove that triangle MLO is congruent to triangle MNO. And then the way that we write this down, as I've told you before, a two-column proof, we're going to basically have two columns, and we're going to have statements right here. So statements, and then we're going to have reasons. So the first thing we always do, as we've discussed in the last unit, as well as this unit as well, we always want to write down what is given. So I'm going to say triangle LMN is isosceles, and then LM, side LM is congruent to NM, and then we have side MO bisects angle LMN. And we know that that is given. And we always write that for the reason, because it's given, we write what's given. And then I don't know how many steps there are to proving what we want, but at the very end, we're going to say for the statement that triangle MLO is congruent to triangle MNO. Okay? And that's where we want to end up. Whenever we're proving something, that's where we want to end up, is down here. So we got to find logical statements to get it to where we can prove that. So now I'm going to go to this triangles diagram and look at exactly what was given. So we know that triangle LMN is isosceles, and it says that LM is congruent to MN. So LM, side LM is congruent to MN. That's what isosceles means. Isosceles means that we have two sides of the triangle that are congruent or the same length. And then it says MO bisects angle LMN. So if it bisects, that means that these two angles, angle 1 and 2, are congruent to one another, because a bisect divides angles into two equal parts. And then we know if it's a bisect, I'm not going to prove that yet, but I will get into that. Okay, so the first step in trying to prove that triangle MLO, this triangle, is congruent to MNO, this triangle, we already wrote down what's given. Now I want to write down exactly what we put right here when I said that those two angles are congruent, 1 and 2. I'm going to say that angle 1 is congruent to angle 2. And what I'm going to put is, since we know that MO bisects side MO right here, or this segment MO bisects angle LMN. Sorry, my microphone cut out. Okay, so now the Bluetooth is back on. Somehow the my Bluetooth wasn't connected. So we know that MO is a bisector of LMN. So it bisects LMN, the angle, and that creates, so we're going to say segment MO bisects this angle and creates two equal angles. So that's why angle 1 equals angle 2, because when MO bisects angle LMN, it creates two equal angles. So I'll just put a bisect creates two equal angles. Okay, now we have a side angle, and then we're going to say a side. We know side angle side congruency is something that proves that two triangles are congruent. And if we look, the next step, we could say side MO is congruent to side MO. And we called that a specific property that we used. And that's known as the reflexive property. So the reflexive property of congruence. So the reflexive property, that basically says that a side is equal to itself. So side MO is equal to side MO, or segment MO is equal to segment MO. So now we have a side angle and a side. Over here, a side angle and a side. So we know that these two angles are congruent because of side angle side, or SAS. Okay, so I just did number 20. I'm going to end this recording and continue on with the other problems in a little bit. I hope this helped you, and I will see you soon. Take care.